handouts I gave you, the next piece we are talking about is the limit of a function. And we've kind of discussed this idea of a limit before because I told you the notation, what we are finding with those slopes is a limit. It's the number we were approaching. And so we've been doing limits. Now we're just going to get a little more precise at it. So first I just showed you a table. If I wanted to know what the function x squared minus x plus 2 is approaching when x is near 2, then you would have to make your table from both sides. So I put a lot of x's on here getting closer to 2, and we can see our y's are getting close to what? 4. Okay, here we're getting closer to 2 from the right hand side, and these are getting closer to 4. On the graph, we can see this is the actual function. It's a parabola. So if you're traveling along this parabola, as your x is getting close to 2, we can see our y is getting close to 4. Alright, the notation, you say limit, and then underneath that, or kind of as a subscript, as x approaches 2, of the function x squared minus x plus 2 is equal to 4. That means when x is getting close to 2, y is getting close to 4. Now, we can see this written different ways. That is the formal definition of a limit. So, an alternative way is f of x is approaching L as x approaches A. I don't really use that notation ever, but you could see it. So it's just saying y is getting closer to your limit as x is getting closer to a certain number A. So it could be written like that. All right, but here's the tricky thing. So in my function, if I just put in 2, 4 minus 2 plus 2 is 4, right? So it's the same thing as just plugging it in. However, that's not always the case. A limit actually doesn't care what happens at that point. It happens as you get close to that point. So for instance, if my function, pretend that line is a little bit straighter. If I had this one, if I wanted the limit as x approached 2 of my function, can you tell me what it's approaching? As x is getting closer to 2, what's y getting closer to? 4. But does the point even exist? No, because it's an open circle. That doesn't matter. A limit doesn't ask you what happens at the point, it asks you what happens as you get close to it. So you can't always just plug in the number to the function. Eventually we'll learn when you can and when you can't, and reasons for that. But right now what we need to understand is a limit is what happens as you approach the point, not necessarily at the point itself. So for example, this is just showing all 3 of these cases have the same limit. This one is the one I just drew that's just an open circle. This one is an open circle, but it also has a dot. So the function is defined there, but it's not equal to the limit value. Or they could be the same. So if I ask you to find the value of this limit as x approaches 1, can I plug 1 into this equation? No, it would be a vertical asymptote. So the function itself does not exist at 1. But that doesn't mean that the limit doesn't exist. So to test our limit, what do you think we could do? Yeah, make the charts. This one's a little bit shorter because we're not finding the slope between 2 things, so we're just really looking at x's and our function. You do have to do both still from both sides of 1. So smaller, maybe 0.9, 0.99, 0.999. Bigger, so maybe 1.1, 1.01, 1.001. And we are plugging them into this function. So you're welcome to grab a calculator. Make sure when you plug these in, you put parentheses around numerator and denominator. Should we divvy up the work? Anna, you've got 0.9, Toby 0.99, Cole 0.999, Tanner 1.1, Bryson 1.01, Hunter 1.001. Toby?
0.50251256
Okay, I'll just do 4 decimal places, but you can do more, it's fine. Cole?
0.50025.
What does it look like this table's approaching? 0.5. Alright, Tanner, what'd you get?
0.4762.
Bryson?
0.4975.
Hunter?
0.4998.
So what are those approaching?
0.5.
0.5. So even though I couldn't plug 1 into this original equation, the limit exists, it's 0.5 or 1/2. Alright. Let's try another one. So if I want the limit as we approach 3, make our tables. What x's should I use? 2.99, 2.999. What about from the other side? 3.01 and 3.001. Alright, can you guys all do the same respective one as you did on the last example? Does that make sense? Everyone knows which one. Anna, what'd you get?
0.3878.
Toby?
0.3988.
Cole?
0.3999.
So what's that one look like it's approaching? Tanner?
0.4118.
Bryson?
0.4012.
And Hunter.
0.4001.
So that one also looks like it's approaching 0.4. So our limit is 0.4 or 2/5. Who wants that? Alright, are we doing okay with this? Let's do a couple more. So this one, if I am approaching 2, do you guys want to try that one? Your tables look like this. So what are they approaching? 0.8. So the value of our limit is 0.8. Doesn't just have to be fractions. We can plug these into any expression. So if I'm looking at this one, again, can I just put in 0? No. But we can do things close to that. So maybe negative 0.1, negative 0.01, negative 0.001. On the other side, positive 0.1, positive positive 0.01, positive 0.001. All right, everybody do your respective number. Plug it in and see what you get. Hannah, what did you get?
0.1001.
Toby? Sorry.
0.1000.
Cole?
0.100001.
All right, so I'm assuming this probably had a 1 there. Can we see what these are approaching? 0.1. All right. Tanner?
0.0919.
Bryson?
0.09999.
Okay.
0.099999.
So what's that approaching? 0.1. So we're still getting 0.1. All right, they both have to match. They both have to be going to the same number. If they don't, then either we've made a mistake or there is no limit there. All right, those okay? We could also do it with trig functions. So let's try that. If I wanted to estimate the value of the limit of sine x over x, can you plug a 0 in there? No, we can't divide by 0. So it's not just what happens at the point, it's as we're approaching it. So my x's have to be close to 0, so negative 0.1, negative 0.01, negative 0.001, and the positive 0.1, 0.01, 0.001. One thing, anytime we're using trig functions in calc, unless you are told otherwise, we need to be in radian mode, excuse me. So flip your calculator, make sure it's in radian mode, and then check your number. Anna, what'd you get?
0.9983.
Toby?
0.99998.
Cole?
0.99999.
I lost track of how many 9s we had.
Yeah.
A bunch. So what's it approaching? 0.1? 1.
The 1.
1. Alright. Tanner, what'd you get?
9983.
Bryson?
0.999998.
And Hunter? A bunch of 9s, I'm
A
guessing.
bunch of 9s. 8.
Okay. So what's that one approaching? 1. So our limit is equal to 1. Alright. We're going to do a couple more. Why don't you guys try this one on your own? 0. So everybody got 0 for every one of these numbers. Alright, so what do we think the limit is? 0. Okay, let's look at the graph. If I graph sine of pi over x, if I zoom in here, what's my graph doing as it's approaching 0? It's going crazy. It's oscillating back and forth faster and faster and faster and faster. So is it actually approaching 0? Not really. What if we went back and like plugged in negative 0.0005? Let's see what happens then. Are we still getting 0? Yeah. But what if I put in like let's try 0.0015. What's that do? We get a different number, don't we? So we just got lucky. The pattern that we were following, it was jumping back and forth so fast, we hit all of the 0 points. But actually, it isn't approaching 0 there. This one actually, we say does not exist. D and E does not exist. Because it's bouncing back and forth so fast. So I did that one specifically to illustrate the downside of this method. It can be misleading. We were pretty confident it was 0, but when we looked at the graph, we saw it wasn't. So this is good, but it is not foolproof. There are situations where it can give us a wrong answer. All right. What about a piecewise function? So if I'm making my table, if I'm doing things less than 0, we know it's a function, so I can only get one answer out. Which of those do I plug it into? Yeah, the corresponding one. Now, I gave you the equation, so you could certainly work it out, but I also did tell you it simplifies. If you plug in anything less than 0, what are we going to get out every time? -1. So this side, all of those are going to give me -1 out. Anything greater than 0 is going to give me 1. And you could certainly plug them in and do x divided by the absolute value of x. That's fine too. So what do you think that means? This one's going to -1, this one's going to +1. What would that be for my rule? There isn't one. If you think about the graph, if you put in a positive number, you're always getting 1. If you put in a negative number, you're getting out -1. And so we can see as we approach 0, we're at 2 different spots. There is no overall limit there.
So there can only be one limit.
Right. So what we've been doing is a 2-sided limit. When I say approaching 0, I mean I am approaching it from both directions, so we can only get one answer. But it is possible to do what's called a 1-sided limit. If I did a 1-sided limit, this would have existed. If I said we were approaching 0 from the left, the notation there to show from the left, you do a little negative sign to show it's smaller than 0. If I'm coming in with x is smaller than 0, what y are we approaching? -1. Or I could have approached it from the right. The number is bigger than 0. And if I'm plugging in numbers bigger than 0, what are we getting? +1. So that is a 1-sided limit. Let's look at this one. If I want the limit as t approaches 0. Okay, so if I thought about my graph, my table here, we can look at a graph, we can look at a table. It's whatever you guys are most comfortable with. Graph-wise, 0 of t is less than 0. So if I put in 0, 0, anything smaller than that, it's giving me 0. 1 if t is greater than or equal to 0. It looks like this. Okay, or if you did your table. All these numbers are less than 0, so every time we're getting out 0. If I put in things bigger than 0 spits out 1. So we can get it from the table or looking at the graph here. Is there overall a limit here? Can I just say the limit at t equals 0? That doesn't exist. What if I said the limit as t approaches 0 from the left? Okay. If I said from the left, that means things smaller than 0. So that's like this table or this section of the graph. What y are those approaching? 0. If I said the limit as t approaches 0 from the right. So from the right, that's the positive side. So if I'm plugging in positive t values or looking when t is bigger than 0, what y is that approaching? 1. So I have a left and right hand limit, but if I said the limit overall, that one does not exist. So individually they do left and right, but because they don't match, there is no overall limit. And that's what our next slide says. We only have an overall limit if the left and right hand sides match up. All right, we're going to do 2 more slides and then we're done for today. If I want the limit as x approaches 0 of the function, where x is 1 if it's not 0 and it's 0 if it is 0. Could we draw a graph for that? We reviewed practicing or drawing piecewise graphs, right? We talked about that and we did it last year. It's essentially making a t-chart for each piece. You would have to put in the 0 here, but since it wasn't equal, that would be an open circle. And every time we're getting out 1. And we use this piece for everything except 0. So we could put in 1, we could put out -1. We're always getting 1 out. So 0, 1 is an open circle. 1, 1 is closed. -1, 1 is closed. It's just a line with a hole in it. What is 0 if x equals 0? Yep, just a point at 0, 0. So what do you think is the limit as x approaches 0? So it's not just one-sided, so it's coming from both sides. If I'm coming from the right, what y are we approaching? That's the 1, the y value. If I'm coming from this side, my y is going to 1. So overall my limit is 1. Doesn't matter that 0, 0 was the point on the graph, because the limit isn't what happens at the point, it's what happens as we approach it. If I'm tracing it with my pencil, what y value are we getting close to? So I want to practice just looking at a graph to evaluate some limits. Right. If I said the limit as x approaches 2, what does this negative sign mean? From the left. So I'm coming in, my x's are smaller than 2. So I'm on this side of my graph. I'm approaching the point when x equals 2. X equals 2 is right here. If I'm getting closer to that point, what y value are we getting close to? 3. If I am approaching 2 from the right, so I'm still coming into this dashed line when my x is 2, but I'm looking at things bigger than 2. So I'm on this section of my graph. What y value is that one approaching? 1. So what if I'm doing both at the same time? If I'm coming in from both the left and the right, my fingers don't match up, so what does that tell me about the limit? Does not exist. Okay. Let's look at the next one. I want to be approaching 5. So here's 5. Right, if I'm approaching 5, the negative says from the left. So my x's are smaller than 5. My x's are smaller than 5, what y is this getting close to?
2.
From the right. If my x's are bigger than 5 and I'm coming in, what y are we getting close to?
2.
So overall, if I'm coming from both directions at the same time, where do I meet up? 2. Because the left and right match, so we do have the overall limit. What if I had just asked you to find g of 5? What's that say? not a limit, just g of 5. It's the function notation. When x is 5, what's your y value? That's the point right here. So when x is 5, my y is 1. What if I had said g of 2? So when my x is 2, what's my y value? Does not exist because they're both open circles. Any questions about this idea of a limit? So we are going to be on this section for the next 2 days. Probably tomorrow I will hopefully finish up the notes, and then the next day we'll have some work time in class for some book problems. But today I do have a handout that you have time to work on.